My name is Alfredo Terrazas, and today's date is May 9, 2021. This is my submission for CIRC11 Attempt C. In this circuit, we use a relay to turn two LEDs on then off alternatively. The source code itself is not complex, so we'll just skim through it as most of the action is happening on the circuit itself. At the top of the source code, we set up the relay to digital pin number 2. Right there. In the void setup code block, we set up the LEDs as output. In the void loop code block, we set up a simple loop to turn the LEDs on, delay for a second, then turn them off, then delay for another second. Notice that we are simply setting a single looping code block despite having two LEDs on the board. That's because the relay is alternating on the LEDs via its internal switch. But before we talk more about it, let's move on to the breadboard and see it in action. As you can see, the LEDs alternate on and off. This is because the relay has a switch inside of this orange casing that switches when energized. This switching is what causes one LED to turn on while one turns off. These two orange wires connect each LED to the pins on the relay, and each connects to the ground on the breadboard via its own 560k ohm resistor. Those two right there. These two wires, these two right here that run all the way to the Arduino, color-coded to represent voltage, connect the 5-volt and ground pins on the Arduino. Right around there. We have matching jumper cables connecting to the other side of the breadboard. These two jumper cables right here. Then two more red jumper cables connect the 5-volt, these two right here, to other pins on the relay, as well as this small one connecting to this diode situated in front of the relay. This small red jumper cable right there, it's a little difficult to see, connects to this diode right in front of the relay. This diode is used to control flyback, which is when high voltage spikes occur while using switches such as the one in the relay. Without proper protection embedded in the circuit, the switches would be seriously damaged and may result in circuit failure. That is why we have this diode to control the spikes, since it's acting as a semiconductor. That's the importance of that diode, which is a little difficult to get from this angle, so I'll move it over here. Right around there, it's right there. Right in front of the relay. This diode connects to the relay via this white wire. This white wire right here. We also have this transistor to switch the current from the breadboard. Transistor's right there, right on that right there. It connects to the relay via this yellow wire, connects to the ground via this black wire, and connects to digital pin number 2 via this blue wire and this 2.2k ohm resistor. That's the resistor connecting to the middle pin on the transistor, and then we have this blue wire connecting to digital pin number 2 on the breadboard. Lastly, this black jumper cable, this one right here, connects the relay to the ground on the breadboard. That about explains the entire circuit. Again, my name is Alfredo Terrazas, and this is my submission for CIRC11 Attempt C.